Okay, so this is activity 10.3, triangles plus 2. The picture shows 3 triangles. Triangle 2 and triangle 3 are the images of triangle 1 under rigid transformation. In other words, 1 is your original, then 2 and 3 are the images of 1. Okay? Describe the rigid transformation that takes triangle 1 to triangle 2. Okay? What point in triangle 2 corresponds with A, B, and C in the original triangle? Okay? So, what I did, if you kind of looked at 1 and 2 by itself, it should look real familiar. Isn't it just like the parallelogram we had in our last activity? Yes, I agree. So if it's just like that, I would say it would have to be 180-degree rotation. And remember, what did we rotate? What was our point of rotation? It was the midpoint, okay? So if we did the midpoint of AC, which would be right here, because that would be 2 blocks that way and 2 blocks that way, so that would be in between, that would be your midpoint. So if we put that, trace it and put it on your paper, and you did the 180-degree rotation, you would see that it would line up exactly with the other one. So it would be a 180-degree rotation about the midpoint of segment AC. Okay? Now, it asks you a few questions. Well, another question here. It says, what points on triangle 2, if we're just looking at triangle 2 up here, okay, from what we did when we rotated it, okay, it says, what points in triangle 2 correspond with B, A, B, C in the original? So if you looked at it, what point do you think would be the corresponding point of A? Remember if this is my line, it would just be in the opposite direction. Remember, if it's 180, so A and C would be corresponding points. And also, if you looked, B and D would be corresponding points, okay? B and D. And let me see, then we had A corresponds to our original C. Okay, so that covers all 3 points of your triangle, okay? All right, because all you had to do was look at your straight lines to the opposites, because we rotated it 180 degrees. All right. Okay, so then number 2, let's see what number 2 says. It says, describe a rigid transformation that takes triangle 1 to triangle 3. Okay, so if you look at triangle 1 and triangle 3, guess what shape that is? Yeah, it makes another parallelogram, so it's going to be another 180-degree rotation. Only this time, I'm going to use AB right here, and I'm going to say my midpoint's right here to rotate it around the midpoint. So I'm going to rotation around, center, around the midpoint. Let's just call it the midpoint of segment, that's AB, okay? So if you want to try it, you get your paper back out. Let's see, I got it traced like that, and I just put me a point there. We start right here, yeah, there we go. Then if we rotate it 180 degrees, lines up exactly on there again. So once again, that is just because you're just going, making your parallel lines parallel to each other. So this one is parallel to that one, okay? And then you got the other ones that are parallel because they're two. If you're looking at your form, let me put my card up here so you can see what I'm talking about. So you just rotated it, and you made the, once again, you made a set of parallel lines here, and then you made a set of parallel lines there, okay? So that was just a 180 degree rotation. Then it said, oh, my light went off. There we go. Then it said, let's see, what points correspond to points A, B, and C. Okay, so if we looked at it, let's see, I would say that point A, my original, point A will be correspond to B. So A will be corresponded to B, okay? Because once again, it's making that 180 again. Then let me see, then you would do B corresponds to A in the original, okay? Then you would say that E corresponds to C in the original. So E and C, these two and these two correspond. Okay, this one, and then A and E, I mean E and C, excuse me. E and C, and A and B in the original. All right. So the number 3, let me push it up so you can see a little bit. Number C says find two pairs of line segments in the diagram that are the same length and explain how you know. Okay, if you're looking at the diagram, let me get my highlighter. I said line segment AE, this is AE, is the same length as BC, this one here. All right. Then I also said that AB, which is right here, is the same size as DC. Okay. Then if you looked at it again, you could find more, but we're just going to do 2 for right now. And explain how do I know? Because this is true because whenever you're doing transformations, using rigid transformations, remember, it always preserves the size or the length of the line. So we never change the length of the line. They always stay the same size. In a rigid transformation, oh, you can't see, can you? In a rigid transformation, they always stay the same size, okay? So anytime you have a rigid transformation, it never changes the length of the line. It preserves the length of the lines, okay? Then 4, it says find pairs of angles in the diagram that have the same measure and explain how you know. Okay, so let me just use my pen here and I'll show you what I'm doing. I said that B and C are the same, and I said that, not this one, excuse me. I'm looking up under here, it's hard to see. I'm at B and D are the same size. But C, let me use a different color. C, right here, C and E would be the same size because if you use your little paper that you traced and you put them in there, you can see that, okay, that's going to be the same over here. If you have this one, if you turn it around, it's going to be the exact same size over here, okay? Then if you had C right here and you flipped it over this way, oh, no, we rotated if I remember right, it would be the same size over here. So C is still the same size. And what can we say about that? We know it's the same size because in rigid transformation, the size of the angle does not change. The size of the angle is always preserved whenever we do rigid transformations. Okay, so that is the end of this activity. So if you would make your corrections in your paper or your book if you need to, and then we're going to go on to activity number, or 10.4. Okay, we'll go to activity 10.4.